So first of all, the thing that you need to know about these two that I've drawn here. So we have a cylinder right here, and we know that for a cylinder, this right here is the radius. In order for these relationships to work, and this is what he kept showing you in the video too, just like when we compare the cone to the cylinder, when we're comparing the sphere to the cylinder, whatever radius the cylinder has, it has to be the same radius for a sphere, okay? Likewise, whatever the height of this cylinder is, so this would be the height of the cylinder, whatever that height is, it also, notice if I draw a purple line here, that is the height of the cylinder. Those two measurements are the same. So the radius and the height are the same. So we are going to start, and I didn't label it as an H for a reason. I'll show you in a second. So it says right here, the formula for volume of a cylinder, because he was able to find some relationship when he filled up the sphere. Do you remember when he filled up the sphere with the blue water and then he filled up the cylinder? How much of the cylinder did it take up? So, did you hear my dog sneeze just there? Anyway, so formula for volume of a cylinder, we know this one. I'm going to leave the V off just so that I can fit it. This is pi r squared h. Pi r squared h. That is how you find the volume of a cylinder. Now, if you recall, well, first of all, here's this. She's sad, I'm ignoring her. If you recall here in a sphere, if this is the same height as the cylinder, this is actually the height of the sphere, but because it's a sphere, remember, definition of a circle, a two-dimensional figure, is that every point on the circle is equidistant from the center. That is also the definition for a sphere. Every point on the sphere is equidistant from the center, but now it's going out in three directions, in three dimensions instead of just two. So what that means is if this is a sphere, this is not only the height of the sphere, we can actually put this in terms of radii. This is the radius, well, so is this, and so is this. So the height of this sphere, we're now going to relabel it. It says replace h with 2r, because the height of the sphere is just the diameter, or 2r. So watch this. Instead of pi r squared h, it's pi r squared times 2r. Okay? Now, what this does is it actually takes out one of the variables for us in our formula, because a sphere, the only measurement you really need, the only measurement a sphere really has is diameter and radius, and those two always fit together. All I really need to know is r. Okay, but we're going to clean this up. The other thing I need to know is that if you remember in the video when he filled up the sphere with blue water, the sphere ended up filling up 2/3 of the cylinder. And what that means is this formula here is going to be 2/3 of this formula here. So it tells me right here, multiply this formula now by 2/3. Okay, 2/3 pi r squared, and instead of h, it's still 2r. Now we're going to simplify. We're going to clean this up. To simplify, 2/3 is a whole number. 2 is like 2 over 1. Those are constant. It's not a whole number. It's a constant. That's what I meant to say. 2/3 times this constant here, 2/3 times 2 is actually 4/3. Remember, 2 times 2, 3 times 1. So that turns into a 4/3. And instead of pi r squared times another r, we know from our work with exponents this year that that's actually going to be pi r cubed. There's 3 of them being multiplied now. And that is where our formula for a sphere comes from. It's not just some random thing made up. It goes with these relationships and how they all work together. Because that sphere literally fills up 2/3 of its corresponding cylinder, then the formula is 2/3 of it. And because we can also replace the height with 2r, it leads us to a new formula. And if I just told you the formula, it would kind of look like random, like whatever, somebody just made this up. But it actually comes from the fact that a sphere is 2/3 of the cylinder. So volume of a sphere, one more volume formula. So here's what we know so far. Cylinder is pi r squared h. Cone is 1/3 of that, 1/3 pi r squared h. You still need the r and you still need the h for a cone. For a sphere, it is 4/3 pi r cubed. 4/3 pi r cubed. Okay, one more formula. And as long as you know the formula and understand where it comes from, then you don't have to go through this every time now. That's the beauty of mathematics and having a formula, is now we can just use this. The only measurement I need to know for a sphere is the radius. And if you look at all 3 of these pictures down here, that is the measurement that is given to you, or that you can easily find, because diameter is easy to get radius. Okay, so There's always someone singing in my house, so you might hear that in the background somewhere. All right, so volume of a sphere. Now notice up here it says, find the volume of each sphere. Write your answer in terms of pi. We're going to practice that like before, and as a decimal to the nearest hundredth. So if you're drawing this on your own paper, you can either draw the sphere, which would just be, look, it's just a circle, and then they have a little oval drawn in the middle to show it's actually three-dimensional. That's the only way they're getting that shown there. So you can sketch this and label it, or you can even just write down for yourself, number 1, r equals 3. That's the important information you need to know, is that if you can visualize what a sphere looks like, you don't even necessarily need to draw it. Just tell yourself that r equals 3. So because r equals 3, I am ready to jump right to my formula. So I'm going to go v equals 4/3 pi r cubed. Plug that in the formula for yourself first. There's no reason to try and do it all in your head, because the place where students make mistakes with the sphere is in working with the cube and working with the 4/3. So I'm actually going to show you how I would type this in and what I would type in first. Please excuse my dear Aunt Sally says to do exponents first, and because I need in terms of pi, I definitely want to do that first. So remember, this is how you type in 3 to the 3rd. Remember, we use that button. If you're using a different kind of calculator, anytime if you're trying to figure out, and it's just a matter of, I don't know how to type it in my calculator, students email me those questions and I can help you figure it out. So 3 to the 3rd is 27. Now that's just this part. If I want it in terms of pi, I don't want to type the pi yet. I want to type everything but the pi. So the 4/3, the easiest way to deal with that is to think whatever's on the top, you multiply by the top, and because that bar in a fraction means divide, you multiply by the top and divide by the bottom. So that's precisely what I'm going to do. Look, I have this in my calculator here, 27, and I just go times by 4, enter, or equals, and then divide by 3. That's me doing the 4/3 and the 3 cubes. So I did 3 to the 3rd, 27 times by 4 divided by 3, and I got 36. So the exact volume of this sphere is 36 pi. And they did not tell me any measurements, so I just won't put any right now. We'll add them on the next ones when they give us measurements. That is in terms of pi. Then remember, all I have to do to get my decimal approximation, here's 36 in my calculator, here I go, times pi equals. Here's my decimal approximation. Now, because it says 113.09 and then the next number's a 7, that's actually going to bump the 0.909 into a 0.10. That's the next place value there. So I'm going to write volume is approximately 113.10. That is my exact volume in terms of pi and my decimal approximation. And that's it. That's spheres. Okay, I'm going to let you guys try 2 and 3. So do me a favor and pause the video. Okay, take a second, pause. And when you pause, you're going to try 2 and 3. Which ones are you trying? Yeah, 2 and 3. Ta-da! And we're back. Okay, so this one, I typed in my calculator 6 to the 3rd. Why did I use 6 even though there's 12 there? Because it very clearly says D equals 12. It shows the line all the way across. That's the diameter. And I need the radius. 12 divided by 2 is 6. So I typed in my calculator 6 to the 3rd times 4 divided by 3, and I got 288 pi. That's my exact answer in terms of pi. And then I just typed in 288 times pi. In my calculator, there's my decimal approximation. It said like 778 or something. So I bumped it up to 0.78, rounding. Okay, this one, look what happens on number 3. So this one, when I type in 5 to the 3rd and get 125, and I go times by 4 and divide by 3. Oh, that tells me that 500 is not divisible by 3. So actually the best way to leave it exact is just to leave it 500/3. You could actually technically also write it like this. You could put 166.6 with the repeating bar with pi, and that's still technically exact. And that is actually what I would do to get my decimal approximation, is leave that decimal and go times by pi. And that's where my 523.0598 means I got to bump it up to 0.60. Which, yes, I could just write 0.6. Since I said nearest hundredth, I just want to make sure you guys understand that's really what I was doing, was the nearest hundredth. So that's the basics of just using the formula. You can get it in terms of pi, you can get a decimal approximation. Then, of course, we have some kind of different, weirder questions, just that we need to make sure we're familiar with how they work. So it says down here, use the formula for the volume of spheres to help you answer each question. First of all, number 4 right away has a word in it that, wait, what? A hemisphere? Do you guys know what a hemisphere is? If you don't know, I'm going to tell you right now. A hemisphere is half of a sphere. It's a half sphere. Hemisphere, half of it. So I'm just going to pretend like this is a normal sphere, and I'm going to go through my work, and I'm going to do exactly what I did above. I know the volume formula is 4/3 pi r cubed. There's only an r in it. No h, and it's an r cubed now because we use the r's to create the h. Keep that in mind. All right, so I see right there, radius of 7 inches. Okay, volume equals 4/3 pi times 7 cubed. And I'm going to type this in my calculator right now. 7 to the 3rd. It doesn't ask me for in terms of pi, so I think I could just kind of go through it. I did 7 to the 3rd first, and now I'm going to do times 4 divided by 3. Got this decimal, that's okay. And now I'm going to times by pi. So this would be the volume of the sphere. That's not what it asked me for. It asked me for the volume of a hemisphere. So if I want half of it, we'll just take half of it. I'm going to divide it by 2. I'm going to take this value here and divide by 2 and my hemisphere. So I got this sitting in my calculator. I'm just going to go divide by 2. So my hemisphere is, my volume of the hemisphere would be 718.38, round that up to 0.38. And this one did give me measurements. It said inches. And just like with the cone and the cylinder, all of our volume is cubes. How many cubes it takes to fill the sphere or hemisphere in this scenario. So hemisphere is just half. Do it like a normal sphere, divide it by 2. We good there? Does that make sense? All right, then of course, just like with our cones and our cylinders, sometimes we have to do these backwards problems where they already give us the volume and we have to figure out the only measurement. The nice thing about a sphere is the only measurement you could possibly have to figure out is either the volume or the radius. That's all there is in this. Everything else is a constant. So in this problem, they tell me that the volume, they tell me already the volume. The volume is 288 pi, and they gave it to me in terms of pi. I really like when they do that. That helps me a lot. So I'm going to say volume. I'm going to plug that in for V, and here's my formula. There's nothing else to plug in. I just got to find R. Okay, some of you get a little like, whoa, what do I do with that decimal or with that fraction? It's a fraction, which could be written as decimal, but I'm going to get rid of the fraction first. If they're dividing by 3, I'm going to times by 3. And if they've got the 4 on top, I can do this all right now. Or sometimes you guys do a little better if we just go, okay, times by 3 and times by 3. Watch what happens there. Those 3's cancel. I'm just going to do 288 times 3. I'm not going to worry about the pi. I'm just going to leave that there. 288 times 3 is 864 pi. And what I have left here is all the rest of this in purple that did not get crossed off. So I have 4 pi r cubed. Try to say pi and 4 at the same time. 4 pi r cubed. I'm trying to isolate the r, trying to get the r by itself. So here I go. I'm going to divide off the 4 and the pi. Whatever I do to one side, I have to do to the other side. The 4's cancel, the pi's cancel. Look over here, the pi's cancel. That's why I love when they leave it in terms of pi. I don't even have to worry about the decimals, the pi's cancel. And all I have to do now is 864 divided by 4. And that gives me 216. Is that the radius? No, it is not. It is the radius cubed. If they have cubed the radius and we're trying to work backwards and get out of that cubing, what do we need to do? We need to cube root. This is something we've done in class before, but I'm going to remind you how to do that on your calculators. I'm going to cube root both sides. This is not square rooting. Be careful of that. It's a different button on your calculator. So don't use this button right here. That'll just square root it. Remember, you have to use the one with the X, and you have to tell your calculator first that you want to cube root by typing in 3 first. So you type 3, and then you do second, the one with an X. Now you just told it the number you want in there is a 3. You told it to do a cube root. Cube root of 216 is 6. Yeah, 6 times 6 is 36, times another 6 is 216. And guess what I just found out? I just found out that the radius of this sphere is 6 inches. 6 inches. We worked backwards. Let's try it one more time. Here I go. The volume, 972 pi, is equal to 4/3 pi r cubed. I am first going to multiply both sides by 3 just to get rid of that fraction. I type in 3 times 972, and I get, I don't know, 3 times 972 is 2,916 pi. Got a little backwards there. That's a 2916, 2,916 pi. And what I'm left with is all this purple stuff over here that didn't cross off. Now I'm going to divide both sides by 4 pi. Divide by 4 pi, divide by 4 pi. 2,916 divided by 4 is 729. The pi's cancel, 4's cancel, the pi's cancel. That gives me r cubed. What do I do now if I want to figure out r? I cube root both sides. Cube root, cube root. Cube root of 729 is 9 inches. I worked my way backwards. They gave me the volume, and I worked back to the radius. So you have to work forward in these formulas, you have to work backward in these formulas. And just one more thing down on the bottom of this page, just to make sure we're seeing the relationship, because these three often come together because their formulas all come from the cylinder. So it says up here, a cylinder, a cone, and a sphere all have a radius of 4 and a height of 8. And frankly, that's the only way it could work if we're doing it for a sphere as well, because 4 plus 4 is 8. That has to be the case for the sphere. And we actually won't need that measurement for the sphere because we just know the formula uses R. But here we go. I'm going to find the volume of each of these. The volume of the cylinder is pi, just a review of all these formulas, pi r squared h. Pi r squared h. And it's going to ask me to compare these, but it didn't say to leave anything in terms of pi. So I'm going to type it all in like this. 4 squared times 8. This is all the everything but pi stuff. And then I'm going to go times by pi. That gives me a decimal approximation. The volume of the cylinder is approximately 402.12. It said feet, so feet cubed. That would be the volume of the cylinder. The cone, the volume of the cone is exactly like that, but it's with a 1/3 first. 1/3 pi r squared h. Do I really need to type all that in again? I have this decimal sitting right here that was exactly this work. I don't think I need to type it all in again. I just need to go divide by 3 because the cone is 1/3 of it. Okay, so the volume of the cone is approximately 134.04 feet cubed. Definitely smaller than the cylinder. It should be. It's 1/3 of it, more specifically. All right, and last one, let's do the sphere. The volume of the sphere is 4/3 pi r. All I need is the r, and I cube it because the height came from the r. So 4/3 pi r cubed. Okay, so this one I'm going to type in again. So I'm going to type in 4 to the 3rd. Here I'm typing that, 4 to the 3rd. That's the the exponent part. And then I'm going times by 4, divide by 3, and times by pi. The volume of the sphere is approximately 268.08 feet cubed. First of all, which one of these is the smallest? Correct, the cone. Which one is next? Correct, the sphere. And which one is the biggest? The cylinder. And that's the order they'll always go in, and we'll use that on the last question here. But first of all, what is the ratio of the sphere to the cylinder? Okay, so sphere, ratio means set it up as a comparison by division or a fraction. There's the sphere. Here's the cylinder, 402.12. Well, watch what when I type this in my calculator, watch, I'm going to go 268.08 divided by 402.12. That decimal, I know that decimal. Do you know that decimal? That decimal is 2/3, which of course it is, because the sphere formula came from the fact that a sphere is always 2/3 of its corresponding cylinder. If it has the same radius and the same height, it will be 2/3. And that's exactly what happened here. The ratio came out to 2/3. How does the volume of the sphere compare to the cone? Well, check out those values here. 134.04, 268.08. This purple number is twice the cone, because guess what? If this is a third of this, and this is 2/3 of this, then this is 2 of this. Did you follow that? So how does the volume of the sphere compare to the cone? The sphere is 2 times the volume of the cone. And the last question, list the figures in order of greatest capacity to least capacity. And we talked about this, but which one of these is always going to be the biggest? The cylinder. Because the cylinder is the full one that everything came from. Which is going to come next? The sphere. Because the sphere is 2/3 of the cylinder. And which one's going to be the smallest? The cone. Because the cone is 1/3 of the cylinder. So it goes biggest to smallest that way.